the gal that does our copies. I went too far one way. Our gal that does our copies has like some cardstock, which is really thick hard paper. I might be able to get a hold of that so we can have some straight lines for this graphing problem here. But if you have anything that has a good edge to it, I mean, even your textbook has a nice, fairly straight edge. Sometimes there's chips in there. Your calculator lid works really good for drawing straight, because what we want to do is make sure that when it says graphing, that we are definitely being really detailed and careful with this. So the first one that we see up here has 2x minus y equals -1. And we have to graph that. Easiest thing for us to do would, of course, be finding the zeros. We're getting pretty good at that over time, you know. We put the 0 in here for x, and we realize, well, it's going to have to say 1, because then it'll be -1 equals -1. And we put a 0 in for y, and we see I'd have to divide by 2. That's going to give me -1/2. Now that kind of worries me, because let's graph those 2 points. Do you see how close they are together? So our line probably isn't going to be fantastically straight if that's all we write down. So then I think, well, the other easy way to graph stuff is y equals mx plus b. Maybe this will be better if I can see it as y equals mx plus b. So if I subtract the 2x and divide by a -1, maybe that will help me out and spread those points a little bit better so I can get a better straight line. So this one now says y equals mx plus b, that we're going to start at 1. Hey, I already have that point on there. That's good. Oh, I wrote on top of the recorder thing. But now it says go up 2 and over 1. That's going to help, because that's going to spread this out a little better. And then I'm just using the slope backwards, so left 1 and down 2. Because then, even if I don't have a ruler, I've got a lot of points up there. I mean, if I just make sure I go through all those points, I should be okay. Oh, is it not showing up really well on there? Yeah, it's probably because of the pink. Yeah. So, yeah, the copies I have are on yellow and white, and that usually does a better job. Are they that bad? Oh, they are, aren't they? It's like the copier was running out of ink. Alrighty, the bottom one, I'm going to color code that one green. That's already y equals mx plus b. That's a huge time saver. So where does that graph start? -2. There. Yep, up 1 and over 2. Rise over run. And doing it backwards, left 2 and down 1. Oh, look at that. I know what my answer is, and I didn't even have to graph that. It's going to hit it right there. But I should keep going, because it said to graph them to find the solution. And I want to make sure I have a halfway straight line. So there it is. And like I said, by using the slope backwards, so going 2 to the left and 1 down, we found out it hit right here. That's our solution. We just have to tell them where that is. -2 what? There it is. Totally checkable. Put the 2 back in for the x and the negative 2 back in for x and -2 and -3 in for y. Check it in both. If it works, hey, it's good. Yeah. Where they hit. That's what we're looking for. That's where the solution is. Where they hit each other. Absolutely. So far, so good? Now, everybody knows you could also solve for y and put it in your calculator and use Blinky to check this too, right? Yeah, if you have time, absolutely do that. But it really goes fast if you just graph it by hand. All right, enough with the graphing on that part. Now, Algebra. So this one says solve the system using substitution. We don't get to choose how to do this one. We have to use substitution. So do you see something that would be super easy to get by itself for substitution? What do you see? Ooh, we get to choose an x and a y, right? What do you want to do? Get y by itself? Okay, let's do that. Subtract an x from both sides. All right. Now this method is called substitution because what are we going to do with that? Substitute it. Where? The top equation. We haven't used that one yet. So this is going to go right there for y. And that's good news because now there's just x's up there. So that means we're going to be able to figure out what x is. So ideas on how we can get it to that point. Distribute a -3. Be careful. It's a -3. Combine like terms. Oh, sorry, and I'm doing the next step. I said combine like terms, but I didn't write it down. Add the 9. Divide by 8. Is that a good sign? Very good sign. We're not going to put weirdo fractions on the tests, you know. There might be some easy fractions like a half, a fourth, or something like that that show up every once in a while. But that's a very good sign. We're not done, though. What's next? We got to find a place to plug it back in very quickly and easily. Get y. Do you see it? Boom, right here. Y equals -x plus 3. Take it back up there. And -1 plus 3 is 2. Should we write x equals 1 and y equals 2 in the blank over there? No. What do we write? The ordered pair. Yeah, use your parentheses. 1, 2. That says we know what we're really looking for is where the lines hit each other in the graph. Even though up here it didn't say solve by graphing, it said solve by substitution, we made that connection and know this is really where these two are hitting. So you're going to have to use substitution for one on the test, and you have to know what it is. Brock, I'm going to take that thing away. This is a practice test. You got to pay attention. Alrighty, elimination. That's not the same. Elimination. You remember that? Eric, you remember that?
Yeah, so you just take it like a subtraction
Okay. Except there was one issue in what you said. We add. Does everybody see why? Add these two, add, oh, look at what happens here if we add -3y plus 3y. Boom. Those already have opposites. We add them. So, I'm not done, right? Then what? Silly Cedar Home, divide by 6. Come on. Oh, so I have to pick one? So the bottom one? Even though the numbers are bigger? Yeah. You know, because we make mistakes with negatives. If you use the top one and you do it right, it's going to be just fine. It's just that we do make mistakes with negatives. So this will say 40 plus 3y equals 46. Help me out. What should we do? Subtract a 40. Divide by 3. And we'll write our answer as 10-2, ordered pair 10-2. Is that checkable? In so many ways. We could put it back into both of these and make sure it works. We could solve for y, and we could put them in the calculator and let Blinky tell us that's where they're hitting. I mean, if we have time, we should know our first three are totally correct before we hand this in. And it's not just the first three. This one says, do it how you wanna. Do you answer your own question? Okay. What are you thinking for this one? Yeah, I mean, look at that last equation there. You're going to get x by itself or y? Does it make any difference? Doesn't, but let's all try to do it the same so we're not, doing three things around the room. So did you get x equals or y equals? Okay. So put this into the other one that we haven't used yet. So 2x minus 3 times our whole lot of negatives, negative x minus 12, equals 6. Carefully distribute, and let's see if we all end up at the same place. I have all pluses now. Did you get all pluses? Okay, keep going. Let's see if we can find this. I stopped at x equals negative 6. Yama. Five x equals negative third d. I'm writing too fast for the smart board today. Did you already get y too? Am I behind you? Yeah. Yeah, because this is going to go right up here. Negative of negative 6 minus 12. Well, negative of a negative is positive. Well, look at that. Does it matter what order we write these two? No, but we do want to remember it should be x comma y. So negative 6, negative 6. Totally checkable. Now we've got 4 problems on the test that we would totally know are absolutely right. And there's a 5th. Look at that. Alrighty, so I want to hear your thoughts on this one. Substitution versus elimination. Substitution isn't going to be fantastic with this one, is it? It'd have a lot of fractions in it, so most people would say, Alright, so now we have to make some choices, some tough choices. Smallest number for 7 and 8 that we could use. 56, ouch, that's big. Smallest number for 5 and 9. 45. Well, working with 5s is a little easier. Do you see how they already have opposite signs? That might not be a bad thing. So let's multiply the top one by 9. And let's multiply the bottom one by 5. And let's see what we get. Take a peek up there. Make sure I didn't do anything wrong. Mine matches yours. Yours matches mine. You're adding them together already, aren't you? Yeah, okay, go ahead. You know what you're doing. Go ahead. Did the 103 make you a little nervous? For just a second? Part of a second? A little nervous? Which one did you go back into to get your Y? Did you do the top or the bottom one? Like the top one with the positives? Not a bad plan. Would it be wrong to put x equals 1 back into the bottom equation? Not if you do the math right. No, it doesn't make any difference. And we write it as the ordered pair. What? 1, -1. Good. 5 questions, and so far, we could absolutely know whether or not we did the front page right by checking our answers. Cool. You go 100%. Flip to the second page. Graph the solutions of each system. We've been doing a lot of this. Take a look at the top one. Notice it's not equals anymore. It's greater than or equal to. How do you get that one graphed pretty quick? Should we use the thumb method, or is it y equals mx plus b? It's y equals mx plus b. So we're going to start at 5. Are your graphs bad on this page too? Oh, they're still pretty light, huh? What's our slope? So down 1 and right 1. We'll do that lots. Should I connect those up in a solid? Does have an equals bar. I don't think we're done. What's the other part, everybody? The shading. Yeah, don't forget to shade. So I'm going to test 0, 0. And it'll say 0 is greater than or equal to -0 plus 5. But we all know there's no -0. So 0 is greater than or equal to 5. That's not true. I can't shade over here. I have to shade up here. And you can feel free to use colored pencils tomorrow. The one danger with that is if you make a mistake, it's really hard to erase colored pencil, you know. So I could always go get another little graph off of one of those sheets over there that we use every day, and we could fix it with some tape. But, you know, feel free to do that. Alrighty, the bottom one. Y equals mx plus b? Thumb method. The zeros. Well, if you put a 0 in for x, it works out really nice. 3 times something is 15. What's the something? 5. If we put a 0 in for y, well, we'd have to divide by 2. 15 halves, 7 1/2. But that's not awful. 0, 5. Oh, look, it hits exactly where the other one did. And then 7 1/2, 0. Dashed or solid? Solid again. We do have an equals bar. Yeah, I'm not as straight on that one because, you know, I didn't have a ruler up here. And then, how do we know which way to shade for that one? Let's give it a try. So 2 times 0 plus 3 times 0 is less than or equal to 15. That's going to say 0 is less than or equal to 15. Is that true? It is. This one shades this way. But Cedarholm needs glasses to see stuff close. I'm going to make sure that she can see where my answer is. Where do you overdo the shading? Overlaps right here. And it isn't just the fact that I wear glasses that you should do that. That's what we always do anyway. So there's no question. That's where the answers are. Got it. Now, if you had time, you check this on the calculator. Everything but the shading. Because you can do y equals for both of these, plop them in the calculator and make sure your lines are in the right spot. But you're going to have to test the points to make sure that they work in there. Alrighty, changing over to number 7, which I know some of you are already doing. Don't forget to look up every once in a while and make sure things are going well. So the top one there, y is greater than or equal to negative x minus 5. What do you want to do? Start with minus 5. Where are you going to go from there? Yes, our slope in front of here is negative 1, so down 1 and right 1. I'm going to give myself something to aim at going in the other direction. Should that be dashed or solid? Solid. It does have an equals bar. Gosh, even my dots don't look straight. We done with that top one? Got a shade. Okay, so Adrian, put the phone away. 0. Greater than or equal to a negative 0 minus 5. Well, we can't have a negative 0. Is 0 greater than or equal to negative 5? Yeah, it's to the right of it on the number line. So this is our shading. Right there. Look at that bottom one. That's different. Yeah, it's a V. There's another thing that's different that we have to be careful of. It's dashed or dotted. It's not going to be solid. So where are we supposed to start that? There you go. That's our new vertex. Negative 3, positive 1. Always the opposite of what we see here. Like so. Oh, boombox making little noises, isn't it? Yeah, what you got, yeah. Up 1 and over 1 for the slope. This one started at negative 5, and then negative 1 is the slope. So from negative 5, you're going to go down 1 and to the right 1 to get that slope of negative 1. So it was here, and then we went down 1 and right 1. It all depends on what the numbers are, Yama. If we have a positive, then we go up and to the right. If we have a negative, then we go down and to the right. Did you already get your V on there? What's the slope for the right side? Down 3, right 1. So how about the left side? Except left. And you told me earlier, don't make it solid, right? Anybody accidentally do that? See, that's going to be the danger with the colored pencils. You really have to think before you do them. Done. We haven't shaded. We got to check for shading. So let's test our good old 0, 0. 0 is less than negative 3 times the absolute value of 0 plus 3 plus 1. Okay, let's see. Got to do the grouping symbols first. 0 plus 3 is 3. What's the absolute value of 3? 3. So negative 3 times 3 plus 1. Multiply and divide left to right. So negative 9 plus 1. 0 is less than negative 8. No. So I can't shade where 0, 0 is. Where do I have to shade? Yeah, on the inside of the V, because with the V's, it's either you're shading outside or you're shading inside. So I have to shade inside. Do you see the itsy bitsy little triangle in there that has both? Yeah, there it is. So we overshade that region. Which, of course, leads us to the whole linear programming objective functions stuff that we see on number 8. Need more time with this. I was looking out and you guys were getting totally ahead of me, which is fantastic from where I'm standing. Fantastic. So that means you're confident and you know what you got going on. Alrighty. Graph each system of constraints. Name all the vertices. Then find the values of x and y that maximize and minimize the objective function. Well, one at a time. I'm going to color code. How are you thinking of graphing that one? Y equals mx plus b or thumb method? Thumb method. It's a nice, easy thumb method one, right? Because if one of them's 0, what does the other one have to be? It has to be 5. 0 plus 5, 5 plus 0. So 0, 5, 5, 0. Dashed or solid? Solid's got an equals bar. Ooh, and that one's a little off, and that's not good with a problem like this. It has to be less than or equal to 5. Is 0, 0 going to make it less than or equal to 5? It sure will. How about, as I switch colors here, this one? I'm going to do y equals mx plus b or the thumb method? Yeah, thumb method will go really fast. These are nice numbers. 0 for x gives you what for y? 4, because 2 times 4 is 8. 0 for y, we cover this up. What would it have to be? It has to be 8. It has to say 8 equals 8. So 0, 4, and 8, 0. Dashed or solid? Testing 0, 0. Should we shade where 0, 0 is? Yeah, 0 is definitely less than or equal to 8. What do those last two constraints tell us? Yeah, so I'm just going to make a big right angle right here and then do my overshading, because then I will know that you know that it has to be positive because of these two right here. Three out of the 4 vertices, we got them. We graphed them. We know where they are. The other one, if we were kind of careful about our straight lines, we can probably just pick it off of here. So what's the easy one to know? Yeah, 0, 0. And I look over here and I see this was my red line. So my red line was out there at 5, 0. I look up here and I see that was my green line, and that one was at 0, 4. Now the other one, I'm thinking is 2, 3. Does it look that way on you guys' graphs? So let's just say I didn't want to have to put it to y equals and use blinky and all that. Remember, I can go back up in here in these two and see if when I put 2, 3 in, it gives me exactly 5 and it gives me exactly 8. And then I'll know, hey, I graphed this right. That's the last vertex. 2 plus 3 is 5. 2 plus 2 times 3 is 2 plus 6, which is 8. Yes, that's the last one. And I don't have to solve for y and put it into the calculator and let Blinky tell me where it is. But it is a test, so if I have time to do that after I'm done, that's not a bad plan. All right, there they are, all 4 of them. Now what? Plug them in. Plug them into what? The objective function. Well, no shocker there. 0, 0 gives us 0. 5 plus 3 times 0 is 5. 0 plus 3 times 4 is 12. And the one that requires a little bit more math. 2 plus 3 times 3. 3 times 3 is 9, and 9 plus 2 is 11. What were we supposed to find? So let's fill out these little blanks down here. We had 0, 0, 5, 0, 0, 4, and 2, 3, and my comma and my 2 are running into each other. And we're not supposed to do the max with this one. It's a good thing I read that. Where was our minimum? 0, 0. 0 at 0, 0. Hang on. Isn't there another blank on your test? So it just had you do minimum. Oh, well, we could do maximum too, but it didn't ask that, huh? Interesting. Okay, so you just have to read and figure out, is it min or max? All right, word problems. Woohoo! Crowd goes wild. Solve using systems of equations. Oh, we know how to do these. You have $5.55 worth of change in your pocket. You realize that you only had dimes and quarters in your pocket. And you count out 33 coins. How many of each do you have? Give me a total. $5.55. That, ladies and gentlemen, is what we call money. So we need to think about what we know about money and dimes and quarters. 10 cents for a dime. Oh, and I wrote that so big I'm not going to be able to show any work up here. So I just made X be my dimes and Y be my quarters. Important to know when we get done. That was not the only total, or we would have to say we can't do this one. There was another total. 33? We got nothing else? Not twice as many dimes as quarters or anything like that in here? And now we have to show algebra. So, substitution or elimination? Yeah, this is a good substitution problem. Look at that bottom one. If we just subtract X from both sides, this is going to go pretty quick with a calculator because we've got decimal stuff going on here. So that will give us 0.10x plus 0.25 times our little negative x plus 33 has to equal $5.55. Like I said, probably going to want a calculator to make your way through this. But yeah, we got to distribute. So, let's see if I can make enough room up here to work. 0.10x minus 0.25x, because we have a positive and a negative. Plus 33 quarters, 825, equals 555. Then what? A negative 15 cents x plus $8.25 equals $5.55. Ooh, that negative makes me nervous. Should it? We're going to get another negative on the other side, aren't we? Because what's the next step? Subtract 8.25. So 5.55 minus what we just had up there is a negative 270. Then divide by that nasty little negative 0.15. $18 somethings. 18 dimes. Now, how many total coins were we supposed to have? So 33 minus 18. Got to have 15 quarters. Totally checkable if we know a little bit about money. Because we can take 18 times 0.1 plus 15 times 0.25 and make sure it comes up to $5.55. There's another one that we will absolutely know that we have right when we get done. All right, 10 is similar. It's actually a little easier. Money brings decimals into the problem whenever you have money. You're selling tickets for a high school concert. Student tickets are $8. General admission tickets are $15. You sell 575 tickets and collect 6,840 smackers. How many of each type of ticket did you sell? Where are you starting? 68.40. What's the other one? 575. Okay, so let's go after the money one first. What do you know about money and student tickets? So I'm going to have X be my student tickets. Got to remember that for later. And Y be the general. Did they say you sold 3 times as many student tickets as you did other tickets? So what do we do about the 575 tickets? X plus Y. Which makes this which method? Yeah, substitution again. It'll go super fast. So we subtract an X from both sides, and Y equals negative X plus 575. And we substitute because that's the name of the method. And yeah, it's got big numbers again, so you probably want a calculator. Do you need me, or are you just going to town on this one? Get the answer. Can't answer, Cedarholm. Doing math. Love it. I got 255 and 320. Is that what you got? So we have to label them right. 255 what? 255 student, 320 general. Label's important. If you just put the answer down there, I'm not going to know which one you thought was which. So Really important at some point to write down X is student, Y is general, and go from there. Almost done. Almost. 11's going to go super fast. Did you already do it? Some of you did, yeah. List all of the points that are solutions. Okay, is A a solution? It's not in the double shading, right? So let's go over here. So C is an obvious choice, right? It's in the double shading. Questionable. B. Why not? It's on a dashed line. See a little trick there? How about D? That's a good one. Any other points that you can see labeled in there? Then we've checked them all. We're good to go. This one, bless you, looks a lot like the carbon dioxide problem that was in your homework. A city wants to plant maple and spruce trees to absorb carbon dioxide. Last one. A city wants to plant maple and spruce trees to absorb carbon dioxide. It has $3,600 to spend on planting spruce and maple trees. The city has 86,000 square feet available for planting. Using the information in the chart, how many of each type of tree should the city plant to maximize carbon dioxide absorption? And the first one is write the objective function. So the objective here is to maximize carbon dioxide absorption. I'm going to make that a C. And I notice in the table, well, there's the stuff I need right there. So if I make the spruce X and the maple Y, then 750X plus 600Y will be representing how I'm going to maximize that carbon dioxide absorption. Now the constraints are from going back and looking for totals. And I saw a total of $3,600 to spend. Now, they could spend less than $3,600. They could spend exactly $3,600, but that's it. No above. And I look at the chart and I see, well, here's money right here. That total was about money. So 70X plus 80Y has to be less than or equal to 3,600. And I also noticed another total, which was 86,000. And that is the space that they have available for planting. And that is in square feet, which tells me area. And I'm looking at this row. So I see that I have a 600 for the spruce and an 800 for the maple. So 600X plus 800Y will have to be less than or equal to 86,000 because that's the space they have. And I don't see any more totals or anything else involved here, but I know that the number of trees cannot be negative. So I have to put X is greater than or equal to 0 and Y is greater than or equal to 0 for my constraints. Now, this doesn't say we are supposed to solve it. We are just supposed to set it up. So with the last problem, that's all we're doing. We're giving them the objective function and the constraints, and then we're stopping. That's the practice test. It has $3,600 to spend on planting spruce and maple trees. The city has 86,000 square feet available for planting. Using the information in the chart, how many of each type of tree should the city plant to maximize carbon dioxide absorption? Blah, blah. C equals 750X plus 600Y. And like I said, I wrote it down in the wrong spot. This should go in B. There it is. Whew. We finished. Not by much, but we finished. You have your little slip for homework.